Ooh, that made me really bright. Wait a minute. Hold on. Okay. Too bright. Happy Wednesday, everybody. Glad that you are here. I'm going to post this book here in a second. I got mine. It's all crispy and new and nice and stuff and stuff. This is a great book. It was at the library. This one wasn't though. I had to get my little copy because I had been using the library's copy. I was like, okay, let me get my own copy. I got mine at Sam's. It's so pretty. That's what we're going to be using. So we're using a book today. Lee, I think I just seen your name pop up. Hello. How are you doing? We're going to talk about expressions and equations. So I'm going to start talking about beginning algebra. Hey. Yes. DC for sure. And there's also, I have the blue book. There's one that is also for middle school math. It says, instead of a pink one, it's a blue one, and it actually says middle school math on it. So it is a good book as well. That's what I started with, was the blue one. And then I found this one, and I started doing this one when I did the TSI test. So these, I like them. I get no promotion for these, but they have them for, let me turn it on the back. Chemistry, biology, geometry. They have all different subjects. They have U.S. history. They have English, computer science. This book was $11.36. $11.36. On Amazon, it's 10 something, like 10.37. Costco probably, because if Sam's has it, Costco probably has it. Because I don't know if I was born in the 80s, but they had something called Brain Quest. Sam's used to sell these Brain Quest cards, and it was like flashcards with trivia and stuff on them. That's who made this. So I'm not sure if anybody is familiar with that, but I was like, I didn't know that until I was like, oh, that's why I'm so drawn to it, because I grew up on Brain Quest. We would take road trips, and we would have our Brain Quest cards and stuff like that. So very much a fan. Let me show you what the inside look like, DC, since you're here. So it's very colorful. It's very colorful. And it's like notes. And then there's also some example problems in it as well. But it's like a little notebook of goodness for your student. I think it's amazing. But anyway, this is what we're going to start with tonight. So we're going to talk about expressions and equations. If you are in algebra class, you are probably talking about this right now. You may still be reviewing because it has only been about 2 or 3 weeks of school. But you should be getting eventually into talking about expressions and equations. Hey, Southern Peach. Hey, y'all. So glad you all are here. We're going to try to keep it an hour. I did upload the live from night before last when we were talking about fractions. And man, I've been so, Lee, I lost all my lives from, not all of them, but a lot of them from July. Because TikTok only holds them for 30 days. And that's on me. I was being lazy. But it's all good. Oh, wow. Yes, I think somebody else up north, yeah. They start this week, but y'all don't get out until what, like June? Hey, Ruelia. Y'all don't get out until Aurelia. Is it Ruelia? Riel? I don't know. Maybe Ruelia. Hey, Jazz. So, yeah. I would definitely get them this book. First week in June. Hey. How'd you do? You need to get this for your kids, Mr. Ford. Tell your students to get this book so they can do good in math. It's not my book, but I just like it. Okay, Ruella. Thank you. Okay, because I want to make... They have one for middle school, too. They have a blue one. I forgot what grade you teach. I think you teach middle school. So they have the blue one for middle school. They have the blue one. Everything you need to ace math. 5th grade? They can do the middle school book. You might as well, because you're getting ready for 6th grade anyway. I would do the blue book. I would do the middle school book. because a lot of the stuff that they learning in 5th grade, they push down. Oh yeah, then I would definitely do the middle school book for 6th grade and just do like the first part of it. Mm-hmm. That's exactly what I would do for her. You have numbers, like whole, integers, rationals, that type of stuff. So in this book, I know in the middle school book, it goes over numbers. This one, the pink book, I got me a crisp copy. It has order of operations in it. That's what we was talking about last week. Let me see, hold on. It has fractions in it. It has a distributive property. Yeah, it has, it's not a lot of it, but it talks about the natural numbers. That right there, that's what y'all talking about? Yeah, in the intro. Yeah, so they have a little bit of it, but it's more in the middle school book. I think they go more in depth about it. Yes, Lee. How soon should a parent introduce that in elementary school? Because that's, well, in Texas, they start in elementary school. Full algebra, I would do 6th, 7th grade. I took algebra in 8th grade. But I would start, go ahead and exposing them to it definitely by 7th grade. Because a lot of students take algebra in 7th grade. Yeah, look into it. If you don't like it, you know, if you get it on Amazon, you can send it back. But I got mine from Sam's today for $11.36. It's so crispy and clean. Let me know what y'all think about it. I think it's great. This one has all sorts of stuff in it. Alright. You learn algebra, well, you probably definitely need this book then, Ruella, because I know that was a struggle. It talks about negative exponents in here. Fractions with negative exponents. It's thebomb.com. Alright, so Avion, I borrowed mine from the library for about 3 weeks and I took it back. I went back today because me being me, no, I had to be very mindful of my funds. But I was so excited because I was like, somebody must have seen my videos. Because when I say every book was almost checked out, biology, geometry, chemistry, everything. I said, okay. Well then. But yeah, I would definitely borrow it. And then if you like it, go buy it. But I like it a lot. And then I'll gift it to somebody when I don't need it anymore. Gravy, it's a struggle. Whatever's in the shelf. I got this from Pop Shelf. It's a something bamboo. I'm gonna look at it before I get out. I'll send it to you. But I get in the shower, wet it, and put some. This is regular conditioner. It's not even leave-in conditioner. That's why. Yesterday it was a hot mess. Hey, Jumpy Jan. But it's like some coconut type of conditioner. I use regular, not even leave-in. I just use regular conditioner. Thank you though. Thank you, girl. I be trying. My best friend saw me today. She was like, yeah, that's so cute. Is it? Thank you for liking the live. Okay. Y'all know you can request to join. I just hate when them 4 boxes be over there. I didn't like it yesterday. I couldn't see. I need my phone already lit. My phone already smiled. Kent says she teach math. Thank you, Kent. Alright, so talking about expressions. This is like, algebra is my favorite subject forever since I was young. My book is so crispy. You know, when it's fresh, it be cracking. So when we talk about expressions, really the only difference between an expression and an equation is that an equation has an equal sign. So an equation has an equal sign. Hope y'all can see that. Let me scooch it over some. So the difference between an expression and an equation is that an equation has an equal sign saying that 2 expressions are equal, okay? An expression is just a math sentence, okay? Or it says in the book it's a mathematical phrase that contains number and letters. So some examples that they give for an expression would be 3x plus 9, negative 7y plus 1/2, and so on and so forth, okay? So an expression does not have an equal sign. But when you get down here, let's say and we want to write an equation, it would be 3x plus 9 is equal to 14. So now I have two expressions. Even if it's a single number, it's still an expression. Okay? Still an expression. It could be x. It doesn't matter. So what you need to understand is that that's the difference between an expression and an equation. Now, this right here and this right here, we call those terms, okay? So this expression has two terms. They're always separated. Hey, Leah. They're always separated by an addition or a subtraction sign, okay? This is what separates the terms, okay? That's how you know when the term begins and the term ends. And it's important to know what a term is, because whenever I start to say, hey, make sure you multiply each term, then you need to understand whenever the term ends, that's because I have a plus sign or a minus sign or something like that, okay? Now, let's talk about term. So let's say I have a negative 7y. This right here is called a coefficient. This right here is called a variable. Okay? So you can have a term, and this is a term too. It doesn't matter. A term can be a number, it could be a letter, and it could be a constant. But whenever you have a variable and a constant together, then that would be a coefficient, and then you have a variable. So you just need to know that. That's all. Thank you, Leah. You just got to know the digits. That's all you got to do. You just got to know what they are. Everybody good? Because one thing you got to understand is your math terminology is very much easy when you understand what your math terminology is. Like if I say, hey, multiply the coefficients together. Lee, why you say that? When I say what? Thank y'all for sharing the live. What you talking about? Oh, is that where Lee come? I always wondered what your name was. Whoever Lee on here liking this live. You too. You know I call you Lee. Because that's all you gave me was an L and an I. Okay, so Ruella, you said that makes sense. Okay, so we got the coefficient, we got the variable, we understand what an expression is, we understand what an equation is. I was sure like, hold on, what I say? No, you so funny. Oh, good, Ruella, good. Hey, Purple Haze, hey. All right, so we got your coefficient. I don't know where Sweets is. She talking about she was ready for today. And Shaprisa, she probably get ready for school. So coefficient and variable. So remember those terms with everybody. We gonna need those. It's separated by plus and minus. So you remember that. And like when you take notes, take them like that. Like I took them. Or I think Willis, you said I was getting it. Because that's how you're gonna remember. Get you some matte pencils. Get you some highlighters. Like get you something to help you. I have like, I don't know if it's called a photo. I think it's a photographic memory. I used to highlight stuff when I would take notes, and then when I would take my test, I would remember what I highlighted in yellow. I could remember, because if I drew a circle around it, I can remember it was in the top right and it was blue. I can remember. So you have to do things, because your mind is a muscle. Your brain is a muscle. You got to train it, like muscle memory. So like when I put my necklace on in the morning, if it's a new necklace I haven't wore and it has a lot of little holes on it, I will clasp my necklace in front of me first. Then I'll take it behind my neck and clasp it, because my fingers remember it. They remember it. Your muscles remember things. That's why when people work out, sometimes they do, I forgot what it's called, but I always say confuse your muscles. They'll do one exercise and then turn around and do a different one and turn around and do a different one. That's why. So that it doesn't learn the same thing. And then sometimes you want it to learn it the same thing so that it can get stronger on that part. It's a method to this stuff, y'all. It's a method to this stuff. Okay. Now, we're not going to talk about polynomials, binomials, and all of that right now. We're not going to talk about that. let us go into what's a constant. So avion, or maybe avion, sorry. No, when you say, because you can have multiplication and division within a term. So let me show you. This right here, 7y, that the operation that's between them is actually multiplication. And let's say you have like 6x over y. This is actually division. So multiplication and division are usually within the term. So it won't separate them. Only by plus and minus signs. So terms are only separated by positive and negative signs. Okay, so y'all remember that. Whenever the term begins and ends, it will be. You talking about this right here? What you mean? Girl, what cool question they asked you? It was asking about separation. Did you just request? Hold on, girl. Let me go grab you. Okay, I got you.
Okay, so it was something like that, but it was like I had to figure out whatever the x equal, but it only gave me the two y's. So like it told me solve for x, but it was like 21y divided by 6y or something like that, but they told me to solve for x. Yes, that just reminded me of that question because I was like, how am I solving for x if I got two y's here? But yeah, that just traumatized me all
Did
over
it say
again.
intercept? Did it say the x-intercept?
No, it just said solve for x, but it gave me two y's.
It might have been talking about invert. Oh, I don't know. They didn't see. That's why I wish I could go take it because I had no idea what they was talking about on that one.
Yeah, I didn't. Me seeing this question just made me remember that because I was sure like they made me throw away my scratch paper at the end because I was sure taking notes on what what I
Right,
was
but
doing.
you
But
gonna choose.
yeah, it looked similar to this, but instead of the y by the x and y, it was seven. Well, the 6x would have been 6y instead.
Okay, so the both of the Y's would have canceled out then. You would have just left. You would have been left with 6.
And that's what I did. I don't. They didn't show me which ones I got right or wrong, but yeah, I
Oh, okay.
canceled out the Y's, and then the answer that I got when I canceled out the Y still wasn't even on there, so I just picked the closest number to it.
Oh, y'all don't know then. That's crazy. So yeah, I wouldn't even know. I wouldn't have. I have to see the questions to be able to say because it's hard when you don't know because you may have to be like, oh, they must be asking me to solve a linear equation or quite, it's something else like a function or something like that. So it could have been something along those terms, but you have to be able to recognize it. So they just do all sorts of stuff. Hot moving mess. Hot moving mess. Okay. So now let us talk about, so we talk about expressions. I want to go into simplifying algebraic equations. So let's talk about simplifying. Whenever you simplify, so that's why you have to know what a term is because you're going to have to simplify it to solve. Okay, you have to simplify to solve. So what are like terms? Well, like terms will always have the same variable and the same exponent. So for something to be a like term, it must have the same variables and it must have the same exponents, okay? So for instance, if I have 7x squared and I have plus 9x squared minus 3x squared, I have to ask myself, do they have the same variable and are they raised to the same exponent? Yes, these do. So I can combine all of them to make a single term or just simplify to make a lower term. whenever you do that, you're going to add or subtract the coefficients that are in the front. Why do you do that? Think of x squared as, let's say, well, this is a puzzle piece that's represented x squared. This is also x2x squared, x squared, and this is also x squared. So I know these are all going to be the same because I drew my box around them to identify that they all are x raised to the power 2. Now I'm just going to add 7 plus 9, which is 16. Then I'm going to minus 3, so that'll be 13x squared. So this will be my simplified answer. Okay, so that would be my simplified answer. And you're only going to pay attention to the numbers in the front when you are simplifying and combining like terms. That's simple. Questions? Everybody okay? Hey, Rogers. Hey, DG. Perfect. Okay. So same variables, same exponents. So answer me this. Are these like terms? If I had 2x squared y and 3xy, would these be like or unlike terms? Are those like or unlike terms? She said immediately no. Immediately no. Even though they have the same variable, the x is missing the power of 2. Perfect. Absolutely wonderful. Has to be raised, the x has to be raised to the power of 2. All right, so what about this? She said immediately no. What if I have 4a squared b minus 12 AB squared? What about those? Would those be like or unlike? Hey, Sally Queen, looking for you. Would those be like or unlike? Nope, very good. But they both raised to the power of 2 though, right? Aren't they both raised to the power of 2? Hey, Mimi. So what's wrong with the same variables? Y'all gonna be okay in this life. That's perfect. Perfect. So I cannot do anything with those. The 2 is not on the right. The 2 it's not on the right number. It has to be on the correct number. Perfect. All right. So we know how to combine like terms. That's how we simplify our equation, by adding the coefficients on the like terms. Hey, Mimi, how are you? Very good. Very good. Okay, so we just gonna keep right on rolling. Now we are going to talk about equations. So we got expressions down. We know how to substitute. We know how to simplify. Let's go ahead and talk about these linear equations in one variable. Y'all ready? I hope y'all are ready. I'm going to erase all of this. Say, we ready. We ready. Oh, somebody had asked to join. Wait, you went away. Never mind. We ready. We ready. Okay. I'm gonna erase this. Is that cool? Y'all good? Everybody should have it. Take a screenshot if not. All right. Perfect. So remember, we need to simplify by combining like terms. Okay, here we go. So let's say that we are given the equation. Let's just do some more simplifying first. Before we solve, 9x plus 2x, and then 12m plus 3m minus m. And then we're going to jump into solving. And then 3 y minus 5y plus 4x minus 1. Okay. 11x, 14m. So we are simplifying. So these we are simplify. Okay, Salad Queen, you said 11x. Oh, that's supposed to be a y. There you go. 14m. So we're just simplifying the expression, and then we're going to get ready to start solving them in a second. Because we got to know how to simplify before we solve. So the first one we got 2x minus 1. So the first one we got, everybody said 11x. The second one, we got 15 minus 1, which is 14m. Then this last one, we got y's and x's and a 1, right? I got 2x minus 1. Don't forget the y. My bad, that was supposed to be a y. 14m. Two y minus 1. So that's an x. So I got y's, I got x's, and I got a number 1. I got a constant as well. No, you're good. So let's look at this. What are my like terms here? I got y's, I got x's, and I got a constant. So I'm going to go ahead and combine these first. I got a 4x minus 2y minus 1 minus 2y minus 2y plus 3x. Okay, very good. So I have a 3 and a minus 5. This is going to give me a negative. Remember, the negative is larger. So that'll give me a negative 2y. I don't have a like term for the x, so I'll just bring it down. I don't have a like term for the 1, so I'll just bring it down, and I have negative 2y plus 4x minus 1. Yes. Very good. Perfect. Yep, if I don't have anything to combine it with, I just leave it alone and bring it down into the answer. If I don't have anything to combine it with, I just bring it down into the answer. There she go. There goes Sweets. I was looking for you. Yep, I just bring it down into the answer. That makes sense? So remember, we can only combine like terms, and if they don't have a like term, then we just leave them alone. Leave them alone. It don't matter what order it's in. Yeah, it don't matter what order it's in. Well, I'll take that back. If it's an exponent, then you would do the exponent, the highest exponent first. You always want to write it in descending order. Good, Jumpy Jan. Okay, so that's why I wanted to make sure we got down simplified. Are y'all comfortable with that before we start solving? And we just going to solve one-step equations tonight. Okay, so let's go ahead and move into, now we're going to start learning how to solve one-step, hey Christy, one-step linear equations. Okay, how exciting. So excited. And when we talk about solving linear equations, remember, so only if I would have been Salad Queen, if I would have been multiplying those, then it would have changed to be x squared. But remember, the x doesn't change. The exponent, if I'm just combining them, it's like I have 9 oranges plus 2 oranges, or I have 9 xylophones plus 2 more xylophones. So always give your variable like an object to go with it. So I have 12, wow, I was gonna say moo-moos. I guess I'm sleepy. I got 12 moo-moos plus 3 moo-moos. Then I lost one of my moo-moos. So now I only got 14 moo-moos. Yeah. Then I had 3 yo-yos. Then I don't know how I lost 5 of them, but I owe somebody 5 yo-yos. So I can only get them 2. I'm still in -2. You gotta think of it like that. Yes, you gotta put stuff with it to make it make sense. Thank you for liking. Okay, y'all good on that? Before we get ready to start solving, we just gonna do a little bit. We gonna do one-step equations tonight, and then we just gonna do the addition and subtraction. Okay. So remember, an equation has an equal sign. That's the difference between the expression and I actually have this on my I don't know where what's her name been at? What's her name? Liella I forgot her name. I don't know. Layla. Okay. So to solve one-step equations, you always have to, our entire goal is to isolate the variable. Anytime it says to solve or evaluate, we want to get the variable along. What about Shabrisa? Sure. Sweets, what you say? Oh, I don't know. Thank you for liking the live. I missed something. Shabrisa, I haven't seen her. I haven't seen her. Salad Queen, I haven't seen Shabrisa today. I don't know where. Hey, Coach Hurst. Okay. So the way we're going to isolate the variable is by using inverse operation. And I like to say that it's PEMDAS backwards. Okay, so I'll show you that in a minute before I write it down. Let's look at the first equation that we have. For instance, let's say we have x plus 2 is equal to 6. We want to solve for x. We want to figure out what x is. I used to teach developmental math at college, yes. So I taught the class that they take before they take college algebra. Yes, coach. Yeah, as an adjunct. Uh-huh. Yep. And absolutely anonymous. When you look at it, it's so easy to be like, okay, it is 4. So let me show you how you got 4. Let's say you said minus 2 to the 12. You just went over it. Yep. Oh, you taking developmental math? That was my class. That was my spot. I did it for 5 years. So what we're going to do is use the inverse operation and unwrap the gift. So since you added 2 to the gift, you're going to take that away. So I'm just going to subtract 2 from both sides. Now you can also write this horizontally versus doing it vertically. And I know somebody said that helped them see it better. So if you want to do x plus 2 minus 2 is equal to 6 minus 2, you can also solve it doing it horizontally as well. So it just depends. So you can do it vertically, or you can rewrite it and do it horizontally. It just depends on what you want to do. So, Barine, no, we are isolating the variable. I guess he meant the x. So when we add this, it becomes 0. It would be x plus 0. We don't write it, so x is equal to 4. Remember how we combine like terms? So you're doing the same thing. You're combining like terms, positive 2 and negative 2. When we add those, that still becomes 0. So now we have x is equal to 6 minus 2, which is 4. So no matter what order, vertically or horizontally, you'll be fine. Oh, congratulations, Coach Hurst. How exciting. I enjoy being an adjunct very much. I would have taught full time, but Abraham, I did 6 minus 2. Yep, so we're not doing the like division, we just subtraction. We just subtracting. We doing opposite operations. Okay? So whenever you want to isolate the variable, you're going to perform the opposite operation of what you see. Congratulations, coach. I hope you get the job. It's fun. It's less stressful for sure. I taught in the district. I taught public school for like 5 years, and I didn't like it that much. So let's look at another one. Questions about that? We're gonna isolate the variable. We just get the x by itself. Whenever you got a variable, you just trying to get it alone. You just don't want it with nobody. It's your x. Put them over there by themselves. It could be a y, and that was like, why you do that? So to be honest, mine was more like a meeting. It was almost kind of like, hey, I know you have the skills to do this, so I'm gonna hire you. It was talk about in the interview tomorrow. My interview was so relaxed and laid back. It was like, tell me about yourself. What type of math do you teach? I think you're gonna be a great fit. And that was it. It was great. It was something I always wanted to do. What subject are you going for, Coach Hurst? What subject are you going for? All right, y'all, that's the next one. X minus 7 is equal to 12. Correct, sweets. X minus 7 is equal to 12. So we're still trying to get x by itself. Remember, like I said, if you want to think of it as doing PEMDAS backwards, since we have x, y, and z, we already have the solution. So we're going to go this way, okay? And you still would include your parentheses and your exponents if you had them. So instead of us going down, we're going up because we have a letter that we're trying to unveil. So you're undoing everything you did. 19, 19, 19, 19. All right, so I got some people saying 5, and I got some people. If you have your master's, though, you may be teaching a higher level math. But yeah, congratulations. That'll be fun. Have a good time. Enjoy it. It's a great class. Yes. So remember, we're doing the opposite operation for those who got 5. If we're already subtracting 7, what do we do? Remember, we have to do the inverse. So we start down here. We have to undo it. Think about everything. It's like I'm unlearning not unlearning, but I'm going backwards with everything that I did. Think about it. If I did x minus 7, some number which has to be bigger than 12, I'm taking 7 away from it. So think about it logically. Math is very logical. There's some unknown value that I'm taking 7 away from that I'm going to end up getting 12. I have quadratic and polynomials on my YouTube. I have like a couple, maybe 1 or 2 about polynomials, but not rationals and not rational functions, but just polynomials, Jenny. I did quadratic. I did the quadratic formula. I'll post that soon. I am waiting with bated breath. You're welcome, Jenny. I know I just said I did so bad I did not put all my lives up. All right, so y'all see it has to be a number that's bigger than that. So I'm going to add 7 to both sides. And what you do to one side, you have to do to the other. If not, your equation is going to be unbalanced. Okay? Abraham, I don't teach geometry. I'm sorry. But I will tell you to get, if you can order this book and get the one for geometry, everything you need to know to ace geometry, it might help you. Now, I taught geometry before for 1 year, and that was it. I'm so sorry. I hate that. Abraham. So x is equal to 12 plus 7, which is 19. So you just want to do the opposite operation. Do you see it now, sweets? Oh, congratulations. At math education, then you can teach anything. Then you can teach, they'll have you doing calculus, trig. So I'm getting my master's in nothing related to math, but yeah, so what you did with a bachelor's degree, you can do development of math as an adjunct. You thought 5 because you did 12 minus 7 and got 5. Ooh, good job, Miss Evelyn. Yeah, so we're not subbing it in. You are adding the opposite. Remember, we have to do the opposite operation. You have to do the opposite operation. No, you just always add by whatever the x is not. So don't get stuck up on like the position that it's in. If it's being subtracted, you add it. If it's being added, then you subtract it. You're doing the opposite operations. So let's do another one. Let me show you. Because it could be in a totally different spot. Think about it as you're wrapping up a present and you're having to unwrap the present, right? You got to take the wrapping paper off, however that looks. So let's say we have, for instance, let's say I have x. Let's say I have -7 plus x is equal to 4. -7 plus x is equal to 4. Let's say we have, so if we know how to, yeah. I'm not gonna say that, Miss Dottie, but it's just always understanding like what's the purpose of what we're doing. We're trying to isolate the variable. And so if I have this problem, where is the variable? The variable is right here. I'm trying to get x on this side of the equation by itself. What do I need to get rid of? We add 7 to both sides. Very good. So I'm going to add 7 to both sides. Now I have x is equal to 11. Perfect. And like I said, you can definitely do it where it's horizontally, where you can line it up like this and you have -7 plus 7 plus x is equal to 4 plus 7, where you have the numbers, directly beside each other, and you can still see that they're going to cancel out, and you have x is equal to 11. Some people like to do it that way as well. Thank you, Jenny. I'm getting better with just ignoring people. Yes, Barine. Yes, Fernando. Yay! Very good. Because usually I be letting people bother me, but so not today, Satan. I feel fancy that I got trolls. That you would take time out of your day to be a hater. I must be doing something right. How you doing now, sweets? You're welcome, Miss Dottie. How you feeling now? Better? Oh, my glasses is tight. Oh. Think you got it? Okay, let's do another one. So let's throw in some multiplication and division, right? Let's say we had 6t is equal to 24. What operation has happened between the 6 and the t? Hey, Tay, what's up? It's been good. What's going on, Tay Ziggy? What's up? It's been so long. Yes, multiplication. How you doing? How's school? Y'all know you finished, right? Who said they want to see the book again? Oh, you buying it? Oh, don't buy this one though. Buy the one for geometry, right? Not this one. It's just yours is gonna say everything you need to know to ace geometry instead of algebra. Yours is like a orange, or it's like a, I don't know. It's a different color. Hold on, I'll pull it up on my phone. Y'all got the answer? So if multiplication is happening, then we want to do. Oh, your birthday was. Oh, happy late birthday! Happy late birthday! Happy birthday to you! Happy birthday to you! Happy birthday! Happy birthday! Happy birthday to you! There you go. Hopefully, it was amazing. It is 4. 6 times 4. Yep. Hold on, Abraham. It's red, actually. That's the book, Abraham. You're welcome. Right, this the good math, huh? Yes, divide both sides by 6. So since we have multiplication, we are going to do division. And we're going to have t is equal to 4. I'm doing like really simple ones so that you get the hang of it. So remember, you are so welcome. Oh, I'm glad you understand, Miss Dottie. So remember, sweets, whenever we do PEMDAS, it's just whichever one comes first, left to right. It don't matter like what order it's in. Multiplication and division. You add and subtract first, then you multiply and divide. Remember, we going this way. We going this way. Okay? And since we are multiplying here, if it happen to be some division, it don't matter. So don't get stuck on that either. Hey, there goes Shaprisa. Sweets was looking for you. So 6 divided by 6 is going to be t, and then 24 divided by 6 is equal to 4. Yep, we going the other way. Hey, Bree. So, yep, I just do this because I feel like it helps y'all understand. We always add or subtract first, and then you multiply or divide for next. You don't. So when we get into two-step equations, then it'll make more sense, because if you try to divide or multiply before, you can, but it's just going to make the equation more difficult. So if you go ahead and deal with your addition and subtraction first, it's going to remove those extra numbers that you don't need, so that you can multiply and divide to get your final answer. Because if you see what's so close to this t is that 6. The only way to separate them with them being so close is by division. And then sometimes if it's being divided, then you have to multiply. That's the last thing you do, because that's the closest thing to it. So it's almost like working from the outside to the inside. And with Sweets was looking for you. You went 24, 12, and 6. Why you skip counting? Oh, you was just trying to get up to what the 4. Oh, I got why. That makes sense. I know why you did that, Mimi. I was on Shaprisa. Hey Jennifer. How are you? I was on last night. I was looking for you. I said, where's Shaprisa at? She started school on Thursday. I don't know. Lee, how you turn the notifications on? Shaprisa say she missed it. I got on early. I was on at 8 o'clock. And I got off at like 9. She said, oh my gosh, okay. Oh, she said, hit the bell. I don't know. Is it 17? Oh, you got it. It's going to be all right. To get X by yourself. Hey, Corey. Is that Corey? Hey, Corey. Yes. You are going to divide. Yes. And Abraham, if you don't like the book, just return it wherever you. I got mine from Sam's. I'm excited. You got 27. You did 135 divided by 5. Let me type it in the phone my own. 27 it is. 27. Why y'all get 17? They must have just typed it wrong. 27. Yes, 27. Perfect. Divide by 5. Yes, Cola. Oh, the phone. Me too. That's all I got. I don't have a regular calculator. Oh, you can't switch the TikTok and the calculator fast enough. So since I'm doing multiplication right here to isolate x and to get it by itself, I'm going to do the inverse or the opposite of that thing. So I'm going to divide both sides by 5. And when I do that, I don't like mixing my marker. X is equal to 27. Perfecto. I thought the 5 went into 13. No. 5 times 2 is how much? What's 5 times 2? Did you? I hope it does you good too, Abraham. Let me know. If not, send it right on back to them folks. So no, Bareen, think about it. If we did 5 into 135, It goes into 1, but then I got 5 and 10, so that's 2 times. That's 10, 35. That's 7. We was gonna say the two-step equations for tomorrow. We trying to ease into it, Shaprisa. We just, woo, once we get this one on lock, we gonna move on to the two-step tomorrow. So, Barine, I love math. Inverse operation means the opposite. So, opposite of multiplication is what? And then the opposite of addition is what? Yeah, 5 is like, give me that money, money, money. Give me that money, money, money. Barine, does that make sense? Why are you so nervous? Yeah, so Barine, inverse operations is just another word to say opposite. Inverse is opposite. That's all that means. It's opposite. Mm-hmm. So let's do one with division. So let's say that I have x is being divided by 3 and it's equal to 12. So x is being divided by 3. So what do I need to do to divide by 3? And we actually gonna use this tomorrow. Multiply by 3. Very good, Melanie. Very good. You're gonna do perfect, Shabrisa. So since I'm dividing by 3, I'm gonna do the opposite of that, and I'm going to multiply. And I put that up there so that you can see when you multiply a number, it goes in the numerator, okay? Anytime you multiply a fraction, it's actually going to be in the numerator. You can do it like this if you want to, and then you can do it like this if you want to. So whenever I have the same number at the top as I do in the denominator, that's going to give me x is equal to 12 times 3, which is 36. Very good, everybody. You all are amazing. That's not that bad. And tomorrow we're going to combine addition and subtraction, multiplication and division. Then we're going to do parentheses. Then we're going to do fractions. Then we're going to do, Miss Dottie, what happened? We just going to keep going and going and going and going. So tomorrow was going to be two-step equations. The next day will be solving equations with parentheses, solving equations with fractions, and we just gonna keep going and going and going. We only on here for an hour. Oh. What did you just do? Oh, I just divided. I multiplied since I was dividing x by 3. Thank you for the likes. I just went ahead and multiplied it by 3. So 3 divided by 3 is going to give you 1. Remember, if you have the same factor in the numerator as you do as the denominator, then it divides away. It cancels out. You are so welcome, Mitch. I'm glad. Yeah. So let's look at another one of division. So whenever you multiply fractions, you always multiply on top, bottom, bottom. So let's say I had x is being divided by 4, and that's equal to 15, right? So since I'm dividing x by 4, I have to do the opposite of dividing by 4. So I'm going to multiply x times 4. So I'm going to multiply both sides by 4, multiply this side by 4. And this is actually like you're multiplying by 4 over 1, but I don't want to get too technical, okay? So just remember, when I have 4 divided by 4, that simplifies down to 1. Okay, sweets, that's why you do that. Yes, so I did 4 parentheses and 4 parentheses because that means multiplication. You can use a dot or whatever you want to do to signify that you're multiplying. But I don't use an x since we already have an x there. It would be like 4xx. So now I have 4 divided by 4. Whenever you have the same thing in the numerator as the denominator, it reduces down to 1, and then x is equal to 60. Very good, very good, very good. Thank you, Ruella. Thank y'all. Oh, the variable in the denominator, that's gonna be like rationals. We not on that level yet, Miss Mitch. We did one like that one night. We was in here for about 30 minutes struggling. Cause then we have to move it into the. It was a hot mess. Are you taking a class that you're having to do it with it in the denominator? Shabrisa, you remember that night we was in here struggling and straining? Hi, Miss Chris. Jumpy, stop, Jans. Johnny, I would have to have go to gym. Thank you, Whitney. Yes, in here struggling and straining that night, wasn't we? Yeah, about to pass out. I was out and got frustrated. Listen. Thank y'all. Oh, you need help with GED math? Jumpy, you better stop giving me right. You making my heart smile. All right, so let's go back to this one before we forget it. Let's do some simplifying and some, we're going to do a mix. We're going to do some simplification, and I think it is Shaprisa too. Yes, it is. So we got 3x plus 2x is equal to 35. I'm starting y'all off real slow. Not just wanted to see one like that. Oh, okay. It's one on my YouTube page. I forgot what week it was, but we did one and we was struggling. Depending on how it is, you would multiply by the reciprocal. More than likely, if it's being divided by x, like 3 over x. Yeah, you would have to ration it. Yeah, yeah. Add your like terms. Very good, Corey. So we're going to go ahead and combine those and get 5x is equal to 25. And then our last step is to do what? Yes, Barine. Yep. Yep. Very good, Kay. She passed it from what? We talk about limit rule. Take the square root if it's squared. Yes, divide by 5. I'm gonna let y'all work that out in the comments. Y'all talking a different level of math. Calculator video on YouTube from Get Some Math. Oh, there you go, Shaprisa. Yes, sweets, we divide both sides. I hope you pray. I pray you do too. Johnny, if what's squared? Oh, my bad. Girl, look, and then wrote the whole thing wrong, guy. That means it's time for me to get off. I done reached my limit. I done got sleepy. It's 9 o'clock on the dot. Oh, look, they giving me a little puzzle piece so that I can confirm that it's me. After about an hour, they make you do, oops, I have to verify. Hold on, that I'm not just sitting here on live. They made me slide a puzzle piece over. Yeah, I changed it to 35, y'all. I just wrote the wrong thing. I just wrote the wrong thing. I didn't get no compression socks. Mimi, that's, oh my goodness. Yeah, see, these are the originals. They used to talk about, go put your compression socks on so we can stay up all night. No, indeed. Yeah, I just wrote it wrong. I'll write it wrong in a minute. It's getting late. Let's do another one like that, and then we probably gonna call it a night just because and then we'll put variables. Y'all ready? We could put variables on both sides. We're not ready for that yet, though. Get my new book out there and see. I'm specific about my stuff. I don't be like to mess up stuff. Hold on. Right. They got people sliding that puzzle. Are you serious? It is. Oh, that's too dark. Okay. So still combining like terms. Let's say you have 3x minus 4x is equal to 2x negative 1, 3 plus 12. There you go. Still combining like terms. Ooh, no. No, Jorge. Oh, Johnny, you're so kind. Nope, nope. Combine first thing we're gonna do is simplify both sides. So if I simplify this side, go one step at a time. So let's simplify this time. This side, sweets. What's 3 minus 4? What's 3 minus 4? Don't get overwhelmed. Let's do 3 minus 4. One step at a time. Negative 1. So now I have negative, and you can write the 1 until you get used to it. 2x plus 12, okay? I still am combining like terms. I still need to put all of my x's on one side and all of my numbers on the other side. So the only way I can move this or remove it is to do the opposite, okay? What's the opposite of a positive 2? That's because a lot of them haven't done it before. So nope, we got to get this over here. I'm adding. I'm not doing. I'm just trying to move it to the other side. Yeah. So what I'm going to do is I'm going to subtract 2x from both sides because I need to move it. The only way you can jump across this little equal sign is by doing the opposite. That becomes 0. Now I have negative 3x is equal to positive 12. My last step. Now I'm back to something I know how to, look a little good to me. Negative 3x is equal to 12. How did I get? My last step is to divide. So I'm going to divide both sides by negative 3. And now x is equal to negative 4. Okay? So just a little extra step. That's why I said we're taking it one step at a time. You still have to combine like terms. Like that's always, you still have to put all your numbers together and all your letters together. You always going to use opposite operations. So if it's over here and I'm using a positive 2 to get it over there with its friend, I got to use a negative 2. If you jump across the bridge, you got to do something a little risque. That's okay. You'll get it. I think y'all be making it. Sometimes you can overthink it. You just always have to remember, I'm going to do the opposite of what I see. Oh, that girl, come on here and talk. There you go. Just request to join. You could have moved to negative 1, but then that would have. So let me show you what happened if you move to negative 1. You definitely can. It's a preference. So negative 1x is equal to 2x plus 12, okay? So let's say I move the 1x over here, right? So now I have 0 is equal to 3x plus 12. You shy. All right. Yep, you jump over the equal, you got to flip the sign. You got to do the opposite. Yep. Miss Dottie, it starts at 8 o'clock tomorrow. Sweet, quit playing. Come on here and talk. Hey, Mimi. Look at Mimi. See, you don't have to be shy. There go Mimi. She got on her. What's up, Mimi?
Hello.
How are you? Okay, Miss Dottie, I'll see you tomorrow. You got a question? What's going on, ma'am?
I just wanted to say you could literally throw away the whole 12 in the beginning of the equation. And I just subtracted 2x from each, like the side of where the like terms are.
Mm-hmm.
And then obviously I got the 1x and I just brought down the 12. Like,
You just gonna disrespect the 12 like that?
yeah, because you don't need the 12 until the end. That's basically when you need it.
You gonna bring them back at the end? All
Yeah,
right, Jumpy Jan.
it's
Yeah, you can
easier
do
that
that.
way.
Huh?
It's easier to do that way.
You think so?
Yeah, because if
Ignore
you're
it.
having issues,
Say
I
it
would
again.
throw away the 12. That's what I did. I just threw the whole 12 away.
But you gotta remember to bring them back though.
Mm-hmm.
That's all. As long as you remember to bring them back, we can do that.
Mm-hmm.
We can do that for sure. Why didn't you move the 2x to the left? Well, we did the first time. You must have just came over here. We did. We did move it to the. We did. This is the second way we did it because somebody had asked me why didn't I move the 1x, and I was showing them this is why I didn't move the 1x because now you got to move the 12 over there. She said, I feel like I'm gonna forget to bring it back. Yeah, that's why. This is the second way we're doing it. So then patience, you would have to minus 12 from both sides. So now you got negative 12 is equal to 3x. You can still do the same thing. You still gonna get x is equal to negative 4. You'll get the same answer, but you got to remember that now I got to move the 12 over there, or you're going to move the 3x over there. So I combined the 3 and the 4, and I got negative 1. Yeah, you still going to get the same answer. As long as you do it the right way. It don't matter which way you do it. As long as you do it the right way, you're going to get the same answer. And everybody solves it differently. I personally like all my x's on the left side. I don't care if it end up being negative or positive. My preference is to put my variable on the left side. I don't care what it look like. But that's just a preference for me. Some people don't like the x to be negative, the variable to be negative. So they may move it to the right side. But whenever we do linear inequalities, it's easier to read it when your variable is on the left side of the inequality. You said Stan, is that because x is equal to... Oh, Sweets is telling her to answer. You said ignore any number that doesn't have a variable. It helps in advanced math. Okay. Idea. Hey, Mr. Wally. Okay, one more and I'm going to bed. Uno más. Uno más. Uno más. I'm going to bed. I know, but everybody was struggling. Why you want to do a two-step equation, Shaprisa, and then you want to do it with a fraction? You're gonna have everybody not want. They're not gonna want to talk to me tomorrow. You think they ready? I do not teach Spanish. I'm learning it on Duolingo. I'm trying to be Oh, you mean like let me see. Hold on, friend. You mean something like, let's say we do 2x plus 8x divided by 5, like something like that? Ooh. You talking about something like that? Oh, okay. Is equal to, I'm making this up. 10x. It maybe end up being a fraction. Okay, so this our last one for it. So at the top, what you say? What's 5? Hold on, sweets. What did you say? Uh, Bridget, you are in class. You in math club class. This is algebra, Mr. Wiley. Yes, we just getting started. I've seen some of your lives before. How that's going to be, yeah. 10 over x, 5 is multiply times 5. Is that what you, I don't even know. So we got 10x divided by 5 is equal to 3. And then you can either multiply both sides by 5 or you can just go ahead and simplify and get 2, depending on what you want to do. So you said 10x over 5 is 5, sweets? Did you multiply both sides by 5 or did you... So if I'm dividing x, because this is actually a two-step. If I'm dividing x by 5, yeah, this is for tomorrow. It's a two-step. Like, so if I just did, if I take that away, but I can't really take it away, I would just have to have x over 5. That's how the social butterfly, that's how the problem started. That's the equation. So if I am sweets, if I'm dividing by 5, how do I undo that? Before you even go any further, if I'm dividing by 5, what do I do to undo that? Right. So I'm going to multiply both sides by 5. Remember, whatever I have at the top, I make it go away. Girl, nah, 10 divided by 5 is 2. Let's say I make that go away. Now I have 10x is equal to 15. That's why you messed up, sweets. Yeah, 10 divided by 5 is 2. It's late. It's like, isn't it 11 o'clock where you at? Ten over 15, Mimi. It's actually 15 over 10. Makes it 3 over 2. Yes, 3 over 2. Yep, we end up doing a two-step. So that's what we doing tomorrow. We learning how to do two steps. Two-step. Two-step. Do my two-step. Do my Oh, it's 10:13 where you my bad. Two-step. 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 Soldier boy, stop. Yeah. Miss Donnie, I thought you was going to bed. All right, so our last step is divide by 10, and then x is equal to 15 over 10. But remember, we learned how to simplify. So x is equal to 3 over 2. Two-step. Nope, P, we going to bed. We've been on here since 8 o'clock. I got to start getting my rest. P Money. We are done. We did this for Shaprisa. Shaprisa wanted a fraction or another 2 something. I ended up giving her what she wanted. Oh, you do? We made it. Yes, we made it, Lee. Oh, Lou. Good night, Sally Queen. Nah, you can turn it into a mixed number if you want to. That's fine. You are so welcome. Nope, you can turn it into a mixed number.